Our next scientist is Jacques Charles. So Charles's law, again, each scientist studied two things, keeping two other things constant. And we're only making one change. So Charles studied the volume and the temperature. So what did he leave constant? Well, if you think of those formulas, the two things he left out were the moles, which are the amount, and the pressure. Those are the things that he didn't change. And so just think about this. If you increase temperature, the molecules are going to move faster. In order to keep the pressure the same, the container would have to expand, so the volume would increase. And so what he noticed that with these two, they were directly related. I don't know if you've ever taken a balloon and put it in like the freezer and it shrinks. So that's kind of what's happening. Hot air balloon, when it heats up, those gases expand, so the volume. So when one goes up, so as the volume goes, I guess I should say as the temperature goes up, they are both related, but as the temperature goes up, the volume goes up, and as the temperature goes down, the volume goes down. And if you ever have to have more air in your tire when it gets cold outside, okay, so volume, temperature are directly proportional to one another. Directly. So the formula here, if you think of that V is on top of that combined gas law and T is on bottom. So this is how a direct proportion looks. It looks like a fraction going on here. So volume over temperature equals volume over temperature is Charles's law. So let's look at our example. A container of oxygen has a volume of 349 milliliters. And it has a temperature of 22. Again, we can't use it as Celsius. We're going to have to use it as Kelvin. So we have to add that 273, so we get 295 Kelvin. What will the gas occupy volume-wise if we change that temperature? So we're making this hotter, so we should see that volume increase because they're directly proportional. So if I add 273 to that, we get 323. And because it doesn't mention changing the pressure and it doesn't mention changing the moles, we can take those out. So here's our formula. And so we're going to have 349 milliliters over 295 Kelvin equals volume 2 over 323 Kelvin. Again, I like to multiply and divide, so I would multiply those two and then divide by the thing that's going to have your x. So I would multiply 349 times 323, and I would hit enter, and then I would divide by the 295. So you should be coming out with 382, and this was a volume. It should match this other volume, so it's milliliters. So you can see gas laws are very, very simple. And let's move on to the next one.